and we could draw curves. We have methods for this when we got y in one side and x in another side, like this. We got methods for that, but this is not, we don't always have y in one side and x in another side. For instance, sometimes we got such an expressions, y squared x cubed minus yx, say plus 5 xy squared equals to 0. And we may, let's give another, and we may be not able to write y in one side from this expression and an expression containing just x and numbers in the right side. But how could we here sketch the curve corresponding to this? This is again by factor. Let me give you an example. For instance, take this expression, x squared minus xy minus 20y squared plus 8x plus 41y minus 20. Okay, equal to 0. In order to sketch the curve, we factor this. I'm just gonna write its factors. This 4x plus 5y minus 4 times 3x minus 4y plus 5 equals to 0. And from here, as before, the product of two things is 0, so that means that the first one is 0. Let me write it here. This one is 0, or this one is 0. And we know the curves corresponding to these two, and they are straight lines. That means that the curve of the original one is the union of two straight lines. For instance, in the y and x, and this y and x things, axis things, is in the analytical geometry or the coordinate geometry or Cartesian coordinates. If you haven't learned that, you learn that some grades later. Okay. For instance, the curve corresponding to the original polynomial is something like this, two lines. Okay, I think that's enough for now. And suppose here, here our polynomial is of degree 2. But suppose, instead of 2 here, we got 5. It be of the degree of 5. And what then? For instance, this be 4, whatever. Then we got our, its factors. Now would be maybe one would be of the degree of 3, another of degree of 2, or couple of them would be of the degree of 2, and the last one of the degree of 1. Which we know how the curves of the degree of 1 looks like, or how the curves of degree of 2 look like, or then but for the higher degrees like this, we do this way. We don't know how its curve may look like, but we do this way using the curve of the simpler polynomials we already know. Okay.